All right, so we've talked a little bit about functions, and we've also talked about being able to add and subtract functions, and also touched briefly on doing multiplication and division of functions. But now we're going to talk about something that we could do with functions called a composition of a function. And that is essentially combining two or more functions, as you could have more than one function, more than two functions, excuse me, and you're combining them to essentially create almost a new function. But there's a specific symbol, there's a specific way to show that they want you to do a composition, and then to evaluate it. And it's really not much different than what we did in evaluating a function previously when we were plugging a number in. So I'll show that here in these two questions that we have. We have two functions, f and g. So f of x is equal to 8x squared minus 3x. And g of x is equal to 11x minus 3. And so we're asked to find the composition, and that's how that's represented, the composition of f and g at when x is equal to 2. And it's shown like this, so what this is showing is we're going to evaluate f of x in terms of g of x. And all that means is everywhere on f of x, where we see an x, we're going to plug in this value of g. And I'll show you what that means here when we're evaluating it. So we've got, we'll come over here and we'll say, okay, this is our composition. And that's equal to 8. And then for every x, we're going to plug in the value of g. So we'll have 11x minus 3 squared minus 3, and we've got an x here, 11x minus 3. So we could multiply all this out and everything. An easier way to do it actually is we could come over here and we could factor. We'll have 11x minus 3 times 8 times 11x minus 3 minus 3. So that's one way that we could represent it. It's the same thing. We just factor out this 11x minus 3 here from these two terms. If we were to multiply that out, that's the same thing that we would get. But we've been asked to evaluate it when x is equal to 2. So f composition g at 2. So now everywhere that there's an x, we're going to plug in a 2. So now we get 11 times 2 minus 3 times 8, 11 times 2 minus 3 minus 3. So 11 times 2 minus 3, that's 22 minus 3, so that's 19. So then we've got 22 minus 3, that's 19. 8 times 19, and I'm not even going to pretend to tell you that I can do that in my head. So 8 times 19 is 152, minus 3 is 149. So 19 times 149 is 19 times 149 is 2831. So now if we were to come up here and what we had originally before we factored it, we could do the same thing. We would get 19 squared times 8. 19 times 19 times 8. And then that's 2888. And then 22 minus 3 is 19. 19 times 3 is 57. 2831. So either way we could do that, and we would still get the same answer. So F composition G at 2 is 2831. Now if we wanted to, and we're not being asked to do this, but just as a demonstration, I'll show you the difference that the composition, the order of the composition makes. If we were asked to do the same thing, but instead we were asked to do the composition of G of F at 2, then we would get, and I'm going to scroll back up here so we can find our equation here. 11x minus 3 is G, so everywhere that there's an x, we're going to substitute our value of F. So 11 times 8x squared minus 3x minus 3. That's the composition of G in terms of F. So if we were to multiply that out, we would get 88x squared minus 33x minus 3. And if we were to multiply that out, I'll just bring this over here so we're not working in complete darkness here. 2 squared is 4, so 4 times 88 equals 352. 33 times 2 is 66, so minus 66, and then minus 3 is 283. So you can see it makes a big difference in what order you do the composition here. F composition G is 2831. G composition F at 2 is 2083, the factor of the 10% basically. So the order of composition makes a difference when you're trying to evaluate the composition of functions. So in our second problem that we've been given, we have f of x equals negative 5x plus 6, and g of x equals 2x plus 5. And we're being asked to evaluate composition G of F at x. So this we don't even have to evaluate, we'll just have to come up with an equation. So just like we demonstrated before here, we'll start with our G, and we'll write out our equation, our function of G of x, and everywhere there's an x, we'll substitute f of x. So G composition F equals 2 minus 5x plus 6 plus 5. And then we can go ahead and solve that for x. So 2 times a negative 5 is a negative 10x. 2 times 6 is a positive 12. And plus 5. So that composition is negative 10x plus 17. And that's all there is to that. I mean, it's very similar to what we did before with just evaluating and simplifying functions, but instead of putting individual numbers in there or a variable, we're substituting in an entirely other function to evaluate and come up with what that composition of those two functions actually is. So that's all there is, and it's a little bit tricky if you don't know what this symbolizes. But once you get that, and once you get the order of substitution, then they're fairly straightforward to evaluate.